All right, so here's 7.3, measuring segments. Please go refer to your notes or refer to the PowerPoint about postulates, the ruler postulate and the segment addition postulate and so forth, and the midpoint. So you need to refer to those postulates because I will be using them as I'm solving here. I'm going to be referring to them. So let's go straight to your worksheet. 7.3, I am going to start with find the length of each segment. To start, find the coordinate of each endpoint. So I don't know if you remember, but in your notes, I said to find the distance, we need to do the difference. If I have a line, I'm going to go over really quick, point A and point B. If I want to find the distance from A to B, okay, from A to B, and there's a point, a number here, 3 and 10, okay, there's a point, there's a coordinate point that refers to that point on the line. So if I want to know the distance, you can see, how do I go from 3 to 10? What is the distance from 3 to 10? That's 7, right? From 3 to get to 10, I have to count 7 units. Well, the way to show that in mathematics, in geometry, is to show the difference between from 3 all the way to, we start with point A, because that's the first number that came. A comes first, so the number 3 comes first. B comes second, so we subtract the point value of B, which is 10, and is the absolute value because distance is always positive. There's no such a thing as I traveled negative 300 miles. There's no such a thing. So 3 minus 10 is negative 7, and the absolute value of negative 7 is 7. So that's just showing how you calculate a distance from one point to another. Okay? So let's go and use this idea right here on our worksheet. It says, find the distance from point P to point R, okay, the segment PR. So P to R is right there. So pretend that you don't see any other points in between, just P and R, okay? So we're going to use the value that is right below P and the value that's right below R. Don't try to do crazy math like, oh, -5 and 4 is -1, that's what it should be. Don't do that. Let's follow exactly what the work says. Well, here we go. The distance from P to R will be the absolute value. The point P came first, so I'm going to take -5, subtract the point R, and right below R there's a 4, so there we go, -4, okay, because there's a subtraction. And then what is -5 minus -4? Together they make -9. And what is the absolute value of -9? Is positive 9. So this answer is 9. Okay? So you have to follow the rule here. Let me go back to my little paper. Is always the distance from A to B is always the number that is below the A minus the number that is below the point B. Okay? So it's a number minus another number. Okay? That's why I end up with -5 minus the positive 4, and then it's -5 with -4 makes -9, and the absolute value of -9 is 9. If you actually count it from -5 all the way to 4, you see that we're going 1, 2, 3, 4, 5, 6, 7, 8, 9 units to get there. Okay? And I'm pretty sure you can do number 2. Let me show you how to do number 3, but I don't want to use this tiny little space here. I'm going to use a bigger space. So the segment from Q to S, I want to know the distance. Find the length of that segment, okay? So Q comes first, S comes second, so it's going to be the absolute value, and it's going to be a subtraction. So I set it all up for myself to solve it. Under the letter Q, I have the number -2. So let me put -2. Under the letter S, I have the number 5. So I'm going to put 5. There we go. Now that I have -2 minus the 5, all I see is -2 and -5 together. Together, these two numbers make -7. And then the absolute value of -7 is just 7. Okay, so that is the answer. The answer for this segment is 7. That's the length of the segment QS. It is a segment because there is no lines under. It's just a segment, a piece of the line. Now take a look at here. Use the number line at the right here from G to I. And there's this little point in the middle, not in the middle, but somewhere in there, point H. If from G to H, it's 31. That's the length from G to H. From G to H is 31. And from H to I is 11. Then what is the length from G all the way to I? Well, we have 31 plus 11. So if you add 31 plus 11, you should get 42. Okay, that would be the entire length. Now, this is easy. They start with just numbers. Okay, but how about if they do an algebraic expression? You do the same thing. The same way we added 31 plus 11, I would add an algebraic expression plus an algebraic expression together. Okay? And that is number 6. That's exactly the point I was trying to make. What happened when they don't actually give me numbers, they actually give me algebra. Here we go. It says, still using exactly the same figure. I have from G to H to I. Those are the 3 points I have here. Okay, it says, if from G to H is 7y plus 3, and from H to I is 3y minus 5. And from G all the way to I, from here all the way to here, the length from here to here is 9y plus 7. How do we solve that? Okay, it's asking me, what is the value of y? Well, I know that if I grab this segment, 7y plus 3, if I grab the segment GH plus the segment HI, it will be equal to the whole thing, which is from G to I. Okay? So I know that if I put them, let me put it up here a little higher. So I have the segment from G to H, which is called 7y plus 3, and from H to I, which is also has its own algebraic expression, 3y minus 5, but together it makes 9y plus 7. So let's see if it's true. Let's put in the place of GH, I'm going to put 7y plus 3 plus, in the place of HI, I'm going to put 3y minus 5, and that's going to equal from G to I all the way, which is 9y plus 7. Now we just need to combine them and see what to get and solve for y. Let's combine like terms. We have 7y plus 3y. That makes 10y. And then we have a positive 3 and a negative 5, which makes a negative 2. On this other side, I have 9y plus 7. Now let me see. I need to solve for y. Why don't I add 2 to both sides? And I get 10y equals 9y plus 9. Then let me subtract 9 from here and subtract 9y from here. 9y minus 9y here is 0. And on this left, on the right side, I only get the number 9 here. And 10y minus 9y is just 1y. So y equals 9. Okay? That's what y equals. Y equals 9. Now I can come back over here. What is the value of y? That's 9. And then it says, find the length from GH to HI to GI. Well, now that I know that the y equals 9, I just need to go back and plug it in and solve for each of those. Okay? So come back and plug in 9 for y here, solve that length. Come back and plug 9 here for y, solve for this length, and come back and plug 9 in here and solve for the length. So this one, I saved it for you to do letter B. Okay? All right, now here we go. A little bit more practice. It's all about measuring segments. It's asking, tell whether the segments are congruent. The word congruent, let's go back here. A quick note review. The word congruent has the symbol equal with a little wiggle over it. That's what congruent means, and it means the same length or size or distance or shape. So congruent means that they are equal in a certain way, either in length or in size. So let's take a look at over here. Tell whether the segments are congruent, if they're the same size, the same length. To start, use the definition of distance, like we were doing right before up here with problem number 1. We were using the distance to see if they were the same size, to find the length. Use the coordinates of the points to write an equation for each distance. Okay, the equation that we were writing there. So let's go ahead and do number 7 together, and I'll let you do the rest. Number 7 says, how about from C to E, the distance, and then let's compare it with the distance from F to D. Okay, let's find out each of them. Okay, so let's find, there's an absolute value and there's a little subtraction for C to E. Let's find what is under C. Under C, looks like it's -9 because right past is -10. Okay, and it looks like it's -5, -6 for D, -7, -8, -9 for C. Okay, so -9 for C. And then let's go to point E. Right here past the number 0 should be -1. And -1 goes in parentheses because I already have a negative. Okay, so -1 I put in parentheses because I already have a negative. Let's go ahead and do the math here. -9 minus a -1. I got to be careful because this is going to become an addition. So it's going to be -9 plus, because of these negatives here, plus a 1. -9 plus a 1 is -8. And the absolute value of -8 is 8. So now I know that the length from C all the way to E is 8 units. And you can even check that. From C all the way to E, if you count it, is 1, 2, 3, 4, 5, 6, 7, 8 units. That's how I do counting. But showing work in mathematics, in geometry, needs to be this way. Okay, showing the distance formula here. Now let's check from F to D. From F, let's set it up already. Absolute values with the subtraction in between. Okay, so from F we have, this is 0, 1, 2, 3. So F we have number 3 minus, let's go D, and D is over here. Okay, from F to D, D is over here right after the -5, which is a -6. So I have to put in parentheses because there's already a negative, -6. Now let's go ahead and do the little math here. 3, this double negative here means +6. And 3 plus 6 is 9. And the absolute value of 9 is 9. So 8 and 9 are two different lengths. And I can conclude that the segment CE is not, so when something is not, we cut it through, like non-smoking, so we cut it through, right? It's not congruent to the segment FD. Okay, that's what we can conclude from that, is that segment SE and FD are not congruent. Okay, not congruent. Right, and here's the work to show it. That always has to be work in mathematics, all right? I showed that the distance from C to E was 8, and from F to D was 9, so they are not congruent at all, okay? And that's what you're going to be doing for the rest of this worksheet, is all about measuring segments. Now let's go over here to exercise number 10. It's saying, use the figure below, right here, and find the values of KL. From K to L, they want me to find the distance, okay, the length. Now let's remember something. Why do we have these tally marks here? I told you in my notes that whenever we show congruent, okay, right here, back to congruent. Whenever we show that something has the same length or the same size, we use the symbol congruent. But we also use tally marks. to say that something is congruent. So for example, if I have this distance from A to B, from A to C, and I want to cut it right in the middle, right here, and put the point B. If I want to show it to you without any words at all, that I cut it precisely in half, and from A to B is exactly the same length at B to C, I just put a little tally mark to say, hey, these two segments right here are exactly of the same size. They're exactly congruent. They're exactly the same size. So that's what you need to remember when you look at at geometric segments and shapes and angles. We're going to learn that we use these little tally marks to say, hey, from K to L is exactly the same length from L to M. Okay? So they're telling me here that from K to L is 3x plus 2. So let me go ahead and draw it bigger. Okay? So they're telling me here that I have K to L and to M. Okay, it goes forever, but we're only considering from K to L and to M. So we have this line right there from K to L to M. It is telling me that this piece is congruent to this piece. They're the same sizes. They're telling me that from K to L is 3x plus 2. So from here to here is 3x plus 2. And this is telling me that from L to M is 5x minus 10. They're asking me to solve what is the value of the distance length from K to L. Well, if they're the same, if they're exactly the same length, I'm going to set them equal to each other. 3x plus 2 equals 5x minus 10. Because they are exactly the same size, you put a tally mark telling me they are the same size. And now we can just do the algebra, okay? We try to get the variables on one side and the numbers on the other side. So why don't we subtract 2 from both sides? And we get, over here 0, we get 3x equals 5x minus 12. Because negative 10 with negative 2 makes negative 12. Why don't I subtract the 5 to this other side? Minus 5x. Minus 5x. And then we end up with negative 2x. Because a positive 3 with a negative 5 makes negative 2x equals, over here we only have negative 12. And then when you divide by negative 2 on both sides, so we can get the x all by itself, x equals a positive 6, because negative 12 divided by negative 2 is a positive 6. Now I know that x equals 6, but that's not the end of my game here. I need to come back and plug it in so I can find the length from K to L. Let's plug in 6 for x. So 3 times 6 plus 2. That would be the length from K to L. Okay, sorry, I didn't see it right there. Okay? So for the length from K to L is 3 times 6 plus 2. 3 times 6 is 18, and plus 2 is 20. Okay? And that only makes sense. Okay? 20. So now I know that from K to L here, that's the question they were asking, from K to L equals 20. And, oh, I'm so sorry. There we go. From K to L equals 20. And I'll let you do the same exact thing for the rest, because it's exactly the same type of work. A little bit of algebra, a little bit of understanding of geometry and symbols. Okay? So, on a number line, the coordinates of D, E, F, G, and H are given here, all respectively. All they're telling me is, if I grab a line, draw it myself, let's see if I have room here. If I grab a line and draw my own line here, and I put all these numbers, all these points respectively. If I put D, and then I put E, and then I put F, and G, and H. And then I assign each of them a number. -9, -2, 0, 3, and 5. Find the length of the two segments. then tell whether they are congruent. It is exactly the same work we were doing before, finding the distance and telling the length and telling them if they are the same length. Okay, so I'm not going to do it for you. I'm just explaining how to set it up for you. They want to see it from D to G. Okay, from D to G, find the length, and then compare it from D to H. Is that the same length? Okay? Don't try to do math in your mind. Set it up from D to G, set up the absolute value, grab the numbers, do the calculation, and see if they are of the same length. Okay? And that is how you're going to be doing a lot of measuring segments. Okay? Is either with whole numbers, like we've been doing here, or with algebra expressions. On your other page here, it's going to be exactly the same thing. Okay? A lot of practice of exactly the same thing. I just want to point out that this two lines crossing over here, you have this two lines crossing over here. I'm sorry, two segments, because they have an end to it. Okay? So this tally mark is telling me that these two segments from R to O is exactly the same size as from O to Q. They're exactly the same size. And this second tally marks, which this one is out of place, should be up here, is telling me that from N to O is congruent to O to P. The two tally marks is saying that these two are the same size, and these two with two tally marks are of the same size. They will give you mathematical expressions. They start with numbers, and then they use some expressions, and they want you to find the value. You're either setting them equal to each other because they are congruent. They are of the same size. Okay? I just want to give you a hint. This is your challenge problems right here, that you really show me you understand how to set things equal to each other and solve it because they are congruent and so forth. Okay? So, good luck with your homework for 7.3.